Welcome to the channel. My name is Austin, and in this video we are going to use a push button and a relay to control a DC motor. I'll show you how to design and simulate the circuit, how to wire it up in real life, and then how to improve the circuit by adding diodes to protect your components from voltage spikes. In this chapter, we are using Proteus to design and simulate a circuit which turns on a motor using a relay switch. The components we are using are a 5 volts battery, a push button, a relay switch, and a 5 volts DC motor. A motor is an electrical device which converts electrical energy into mechanical energy. A relay is what we use to switch high power devices. A push button is what we use to complete or break a circuit, and a battery is what powers the circuit. So let's talk about the relay switch. A relay switch consists of 5 pins, and these are the common, the normally closed pin, the normally open pin, positive pin for the coil, and negative pin for the coil. So how does a relay work? When current flows through the coil, it generates a magnetic field which attracts the internal pin from the normally closed pin to the normally open pin, completing the circuit, and this is what turns on the motor. So let's start the physical connections. So we connect the positive terminal of the battery to the push button, and we connect the push button to supply power to the positive terminal of the coil, and to also supply power to the common of the relay. We proceed to connect the normally open pin to the positive terminal of the motor. So that's it for the positive connection, and let's start connecting the negative terminals to ground. Alright, so connect the negative terminal of the motor to ground, negative terminal of the coil to ground, and finally the negative terminal of the battery is also connected to ground. So this is our basic circuit, and let's briefly run through it. So the battery is connected to the push button. Push button supplies the common and the positive terminal of the coil. Normally open pin is connected to positive terminal of the motor. Negative terminal of the motor is connected to ground. Negative terminal of the coil is also connected to ground, and finally negative terminal of the battery is also connected to ground. So let's run the simulation. Alright, so when we hold the push button, the motor turns on, and let's explain this. Holding the push button completes the circuit and current flows to the coil. So when current flows to the coil, it generates a magnetic field which attracts the internal switch from the normally closed pin to the normally open pin, completing the circuit, and this is what turns on the motor. So when we release the push button, it demagnetizes the coil, and the internal switch moves from the normally open to the normally closed, and this turns off the motor. So this is our circuit, and we are also going to build it physically. In this chapter, we are looking at the physical connection of our circuit. So the orange jumper wire is connected to the 5 volts pin, and the black jumper wire is connected to the GND. I will proceed to connect these jumper wires on the breadboard's positive and negative rails. From the positive rail of the breadboard, I will connect our push button, and from the other side of the push button, we connect a jumper wire to the common of the relay. We proceed to connect the positive terminal of the relay's coil to the common to form a junction with the power from the push button. And then we ground the negative terminal of the relay coil. We proceed and connect the normally open pin of the relay switch to the positive terminal of the motor. And then finally, we ground the negative terminal of the motor. So that's our basic circuit, and we are going to test it. In this chapter, we are going to improve our circuit by adding a diode across the relay coil and across the motor to protect our components from voltage spikes. A relay coil and a motor are inductive loads, and inductors hate a sudden change in the flow of current. So when we release the push button and switch off the relay and the motor, the coils inside behave like they want to keep the current flowing. So the collapsing magnetic field generates a voltage spike which can destroy the components. So to fight this danger, we add a flyback diode across the relay coil and across the motor to provide a safe path of flow of current to avoid damaging the components. So we connect the cathode of this diode to the positive of the coil, and we connect the anode to the ground. And for the motor, we connect the anode to the negative terminal of the motor, and then we connect the cathode to the positive terminal of the motor. So these diodes basically provide a safe path of flow of current to avoid damaging the components. So that's how we improve our circuit.